Okay. Quick comment. I am recording today because one of our students is gone and has asked me to record this lecture. You guys can do me a favor, and if you notice this blue light turn off, let me know, because it means that the camera can't hear me. I'm pretty sure the blue flashing means that it's working. Pretty sure I have other batteries, and it will die before the end of class. It just doesn't have enough light for our entire class. So you guys can spot that better than I can. So today we're doing lecture 5, courses. I did want to make some lab comments really quick, since I turned back your first lab. For those of you who sent me your lab electronically, I used my grading rubric sheet in order to mark your scores on there. So some of you got that, and some of you got your hard copies that I actually just wrote on. So that's why there's a difference. If you're wondering what the lab grade is based on, you can go to the course website under course materials, general documents. There's something called the lab grading rubric, and it outlines the 5 major areas that I grade on and what I expect in those areas to include. So some things I noticed. Apparently me hammering up here on the board about quadratic is not exponential wasn't enough. So what I don't think I ever put on the board, and I'm going to do it now, is the actual equation, because so many people refer to the quadratic pattern as going upwards exponentially, or the inverse pattern as decaying exponentially, or the inverse square pattern as decaying exponentially. So again, exponential is not a qualitative term to describe upsweepy or downsweepy. It's not a qualitative term. It has a mathematical equation. The equation for an exponential function is a e to the x. That's an exponential function. If something has an exponent, that doesn't make it an exponential. Okay, so just because you see an equation y equals ax squared, like we saw with the quadratic pattern, it has an exponential. That doesn't mean, or sorry, it has an exponent, but that does not make it an exponential function. An exponential function is only one thing and one thing only, and it's that. We have not seen that pattern. This is very rare in nature. Radioactive decay, population growth. That's right. So it doesn't come up. That's why we don't do it as one of our 4 major patterns, because the 4 major patterns come up all the freaking time. So I just want to make sure before the test next week that we really, really understand that exponential is this. This is quadratic, and the 2 are not the same. Definitely not the same. Okay. I marked this on your papers, but I'll just say it for everyone. When you're showing graphs, you don't need to show your raw data table right next to it. It's the same thing that you graphed, except the graph is more visually pleasing. So showing the raw data and then showing the graph is very redundant, and you wouldn't do that in a scientific paper. You don't need to show the raw data. That's what the graph is for. So don't do that. When you're titling your graph, oh, this one. This is, I don't know, this is probably not standard math class stuff. But if you're at a loss for a very clever title, don't even bother. You don't need to be clever. It's fun to be clever. I'm not a very clever person, so I just go, okay, there's a formula here. The formula is y versus x. It's always y versus x. It's not x versus y. So if your y-axis is stretch and your x-axis is period, then you could call this something elaborate, like how the stretch affects the period. no, stretch period. What am I doing? Stretch mass. I'm mixing up these experiments. How the stretch of the spring affects the mass. That's an elaborate title. You don't even need to be that elaborate. You can just say, stretch of the spring versus mass. Titling 101. Y versus X, not X versus Y. Yeah.
Can you do stretch versus mass, or is that too small?
Stretch versus mass is probably fine in the context of a lab report where you explain what the heck stretch is.
Okay.
So it's, yeah. If you were to just say you're going to a poster conference where you're presenting a poster and people aren't going to necessarily read all the details of your report, you probably want to have a more clear title to explain what the data is. But if it's in the context of a report someone's reading, then stretch versus mass is just fair. And I would never mark you down for that. It's just like, you know, this is a skill, we gotta learn it, so. Some people miss the boat that beginning of your lab packet, can I borrow one of yours? Whether you didn't see this in the lab packet and you didn't hear us talking about it over and over and over again in class. But at the beginning of the lab packet, there was a basic conclusion guide that gave you a very formulaic way of writing your conclusion. And some of you did that. Some of you did not. And you lost a lot of points for it. So you just got to follow our instructions. A lot of people don't seem to know how to use this table, so I want to go through how to use this table again. All right, so if you collect data, since we're doing, oh, I got to grab over there, what am I doing? You do stretch versus mass, and you add, 50, 100, 150, 200 gram masses, and you get stretches in the range of 1 to 4 centimeters. And you're making a prediction about how much your spring would stretch if you added 400 grams mass. This is your data set. You plot a line, and then out here at 400, you examine where your fit would be. So this point, your prediction is outside your data set. A lot of people said that their confidence was high. In none of these experiments could you ever have a high confidence because every single one of our experiments, your prediction was outside your data set. So when you're looking at this table, along the vertical axis you have predicted value within your data range, predicted value near your data range, predicted value far from your data range. So for all these experiments, you had to qualitatively decide whether your prediction was near or far from the data range, but in none of the cases was it in the data range. So let's say it was near the data range. Okay, so that's one reason that you can have your confidence. You have to have two reasons because there's the vertical axis and the horizontal axis and the vertical axis. So reason number one, predicted value is near my data range. Then I look at the fit and I say, well, that's actually a pretty darn good fit. The best fit line is near the center of nearly all my data points. The best fit line is near the edges of many of my data points. Or my fit sucked, so I better consider some new physics happened going on. I'm going to go with the best fit line is near the edges of many of my data points. So predicted value near the data range, the best fit line near the edges of many of my data points. That makes my confidence medium. I would say that's probably appropriate for most of the experiments we did, unless you collected really bad data and your fit didn't fit your data very well. So when you say your confidence and reasoning, you'd say, I have medium confidence in my prediction because the predicted value is near my data range and the best fit line is near the edges of my data points. So you have two reasons, and you just read it right off the table. Thank you, Alicia. Okay. That was it? Okay, so those are the things that I felt that were not conveyed well by me when we were doing the lab, because I saw a lot of people clearly not understanding what I had intended, so. But that's good, we had this conversation, and next week you guys have your midterm, so hopefully you'll do awesome on those parts of the midterm. If it comes up. We won't do the confidence and prediction thing on the midterm, because then I'd have to provide the table, and that's one more thing to print, so. Okay, another comment. I attempted to upload a new syllabus last night, but my internet kept going in and out, so I couldn't actually upload the new syllabus. But because we didn't start Lab 2 last week except for one group, I think you guys were the only group that did Lab 2.
Bonus point group.
Yeah. Oh, they got it. They got their bonus points. So
Yes,
and
it can be done.
early.
You can get it in the cup.
It wasn't even generous, like it was pretty well right at the center of the cup.
Well, that's good data collection. You know, I won't say that it was lucky. It was just good data collection. You get it in the cup, you get your 3 bonus points. So you guys can do that too today. So Lab 2, we're doing that this week. So obviously Lab 2 is not due today, as the syllabus says. Because if you turn, you'd be like, well, I didn't do it. I don't like having labs due on the midterm, but looking at our schedule for the term, the alternative would be to have it due on a university holiday. People go, what? You can't do that. Okay, well then have it due the next week. Well then you have like 4 weeks to do Lab 2. So I decided we're gonna have it due next week, the same day as the midterm. Please do your lab early so that you are not spending quality midterm studying time doing your lab. This takes a lot of personal responsibility, right? Do your lab, say tomorrow. And then Friday through next Tuesday, you can just study the heck out of physics and not worry about Lab 2. Sound like a good plan?
Or your other class.
Right.
Let's do that. Yeah, and it's just a fill-in packet, you know, so you can get 90% of it done here, go home, finish it up, and then you don't have to worry about Lab 2. Just turn it in. So, okay, so I will upload a new syllabus with that change as soon as I have internet at home. I don't know what's going on with it. Okay, so that's that. That's all the stuff I wanted to cover before class. So what we're doing is a concept review of Lecture 4. We're going to learn all about forces today, do some problem solving, review for the midterm, and not do Lab 3. Man, didn't fix that. Okay, Lab 2. Okay. I went to this conference this last Saturday, and it was like amazing. I've heard about the flipped classroom approach before, and it's totally in line with these alternative teaching methods that I already like to employ. The flipped classroom is taking it one step further. So instead, I'm not doing it right now. I'm so excited I'm going to do it next term, but I'm going to try it out at some point this term, and I'll give you some warning when we do it that week. But how it would look is I would go work in one of the classrooms with a smart board by myself, and I can annotate on my PowerPoint, and it's recording everything I say, and it creates a little video. And I can do all of this introductory lecturing crap at home, well, I mean, by myself in another room, upload the video to the course website. You guys watch a 20-minute video introducing forces, for example. You do a little worksheet at home, like a quiz, to make sure that you understood what you saw. And then when you come to class, instead of me yammering away at you, we just problem solve. We just do stuff and make sure you get it. It sounds fantastic, doesn't it? Instead of me just like, blah, 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 let me tell you what the book said. Anyway.
Well, I don't read the book as much just because that thing is just a dead weight to me.
Well, that's the other part of it, is effectively integrating reading skills into this class. So you learn how to read better. because most of us don't know how to read textbooks, and this textbook is so dense, there's a whole lot of stuff in there that we don't need to read. And if you aren't really clear about what it is you need to get out of the text, you can end up reading a lot, and then you come away going, oh God, what did I just read? So I had these reading quizzes incorporated into this class, and I think they're great, but they do suck up a lot of time, so I cut them out. But what I'm envisioning this class being in the future is there would be all that stuff online before class, and we would just get to leave like an hour and a half early. So you do some of that work at home, where you watch the video lecture, you do a reading quiz, you know, so that you come to class and you've kind of already been introduced to the concepts, and then when we're here, we just work on those concepts and practice problems and stuff, and then we go home early. Well, it's hard to feel out what that will look like when it's new.
I've actually had a fit class before at CCC,
Yeah,
and it was really productive for like the students there because they could choose what time is best for them to watch the lectures. And also they could rewind the lectures back in case they missed something in the lecture because it's a video.
yes.
And then
yes.
when we got into class, that's when they could ask all of their questions because they already knew the concepts and everyone knew the concepts and was expected to know them from the lectures. And then that's where all of the like problems that people had with certain problems or certain things were resolved.
Yes, yeah, and that's how it should work if it's designed well. And last spring I recorded my 223 class. I think I recorded like every single lecture and uploaded the videos to YouTube. And I got a lot of feedback from students. They liked that because they'd go home and rewatch my lectures. So it's sort of like backwards. So they come and hear the lecture and not get anything out of it, and they go home and rewatch the lecture and actually learn it. My goal is go home and watch the lecture and learn it, and then come to class and get ready to use it. So I'll give you some warning. I got to mess around with the smartboard, and if it's really user-friendly, then after the midterm, I'm going to try it out, and I'll say, okay, this week you have online homework that's due before class, but we're going to get to go home early. So I'll give you lots and lots of warning before I do that, but I'm just so excited to try it out.
Could the quiz be participation? Because what if we
The
just
reading
don't
quiz?
understand it? Yeah.
I don't know, I'll have to think about that, because there's things that, I'll have to think about it.
Or like a pass fail. And
Yes,
then
maybe like a-
unlimited retake.
Or a retake, maybe a retake option, so that, because I want to make sure you know the stuff,
Yeah.
but it's understandable if you read the text and you just don't get it, and then you come to class and you get it, and then you want to go home and retake the quiz, that would actually work out really well.
Yeah.
So, yeah. A lot of this is just building the infrastructure, and that takes time, so that's why I can't just like go, oh, we're just gonna do this from now on, because it just takes a lot of work, so. Okay, so we're just gonna do it the old school way, and I'm just gonna suffer through lecturing at you. Okay, I'm actually gonna pause the video and restart it so that I have a nice cap on that comment, that little discussion.